So hi everyone, today I want to talk about having a shorter feedback loop using a method called partial testing. So before starting, let me introduce myself. So my name is Mathieu Kniewallner. I've been a software engineer at BackMarket for a year and a half now. I started in a feature team and then I moved to a team that is focusing on the developer experience. And I previously worked on GraphQL, REST APIs, and microservices at Dailymotion for almost 4 years. So partial testing. Before explaining what partial testing is, let's start with some context so you have a better background of why is it needed and what it is. So a bit of background. So at BackMarket, a big part of the technical stack is a Django monolith that clocks to about 320, 1,000 lines of code, not including the test. And we are moving to microservices to avoid keeping a monolith, but we know that it will take time before we can get rid of the monolith entirely. So this is here to stay for quite some time. We have about 30 pull requests per day from different feature teams working on the monolith. And it takes about 45 minutes to run the full test suite locally because we have about 18,000 tests, so it's quite a lot. Code base is split into multiple applications, but most of them are interconnected because we make heavy usage of the ORM of Django, so we have a lot of interaction between the different applications. So it makes it hard to know how a code modification will impact other part of the code, and we don't really know as a developer which test to run based on the code that is modified. So what most developers used to do for testing? It's clearly not an option to run the full test suite locally because 45 minutes is a lot, so it will be really painful for the developer to run the full test suite. And when the impact for the developers is not clear, when he's updating code, the developer will usually push the code to Git. Then the developer will hope that the CI will be green, and sometimes it's not. So the CI takes about 10 minutes to run the test, so it's way better than the 45 minutes on local environments, but it's still a lot of waiting for the developer, especially if the developer doesn't know beforehand if the CI will be green or red. So in case the CI is red, the developer will basically update the failing test and push to the CI again. So they will need to wait for, again, 10 minutes. So overall, the feedback loop is pretty bad for the developer. So at this point, we asked ourselves, what if there's a way to only run the test impacted by the code that is modified? So that's where enters the coverage library. So I'm probably sure that most of you know the coverage library, but for those that doesn't, it basically is used to detect which code is tested. So you get to know the percentage of code that is tested for each Python code file. But a new feature that was out with version 5 of coverage is a way to know which part of the code is covered by which test. So this seems interesting because with this we could know the code, the test impacted by the modification in the code. So to use the feature, it's as simple as using dynamic context equals test function in the coverage configuration. And it will generate an SQLite database with the information we need. So I will cover this a bit later. So if we analyze the tables that are generated by the coverage SQLite database, we have 7 tables, but the most important ones for us are the act, context, and file. So I will show you what those tables are about by doing a little demo. So here I have a project that is set up and that, oops. Font size. Right. Font size. Sorry.
You can do Command Shift plus, like in the
Okay.
browser.
Command Shift.
Or not.
Nope.
Maybe in View.
Yep.
I
Sorry.
There's a place to do it really quick.
Oh, maybe there.
That
No?
may help.
Ah. Okay.
Yeah,
But it will be hard to switch between.
You need to switch files.
Okay. I know. I manage. Okay. So here we have a simple application which defines some configuration for the coverage data library. So we added the dynamic context equal test function as stated earlier. And the application is quite simple. So we have a partial testing demo module that holds three different files. So we have utils.py file that will just count the number of items that are in a list. We have a method called countCars that will basically count the number of cars by using the method defined in the utils method. And we have the same thing for another method called countAnimals that will also call the count items in list method from the utils. And for the test, we have basically a test case for each of those methods. So utils will test the util method, car will test countCars, and animal will test countAnimals. So it's quite a simple project. And then, sorry. Up. So if we run the code through coverage, so it will run the test as we could expect. And then if we take a look at the database that is generated, so we can see that the coverage database is there with the tables we've shown in the slide. And the first interesting tables is called arc. File. So it will basically hold all the Python code files that are in our code base. So you can see that I have the three modules, animal, utils, and car, and the init.py from the module. So the second interesting table is called context. So it will basically hold all the test functions that we have in our code base. So you can see that we have all three test functions in the table. And the final interesting table for us is the arc table that holds the mapping between the file and the context. So basically, you can map a code to the test file. And you also have precise way to know which exact part of the code base is traversed by the test function. So by doing that, with all this information, we can have an SQL query that could return exactly which tests are modified by the file that we are modifying in Python module. So if I run this query, we'll see that I explicitly pass the file that I potentially modify in my code base, and I will select the context to get the list of tests impacted by the modification of the file. And so if I run the query, all right. Then if I run the query on car.py, as it's not included by any module in my application, I will just have test countCars returned because I don't have any module using this module. So the same goes for animal because it's not called by any module in my code base, so it will just return test countAnimals, which is to be expected. But if I check for utils.py, then I will have 3 lines return because utils is included in both the test utils method that test it, but it's also included in animal and car that both make use of the util test method. So this means that with that information, we are able to know, regardless of the deepness of how many functions we traverse, we have a way to know each of the tests that are impacted by a modification in our code base. So you can see that we have countCars, test countAnimals, and test count items in list. So basically, with this information, we can precisely know whenever a code is modified, which tests are impacted by this code modification. Oops. So let's go back to our question earlier. So what if there's a way to only run the test impacted by the code modification? So it seems that there is a way to do that. So now we can maybe experiment with the solution to see if it fits what we want to achieve. So partial testing is not a new thing. There's already two libraries that handle that. One is focusing on PyTest. So as a code base, it's a Django monolith using unit test modules. It's not possible for us to use it. And the other one is partial testing that basically uses coverage to get the report based on the dynamic context, as we've shown. So this is the first thing that we started to try using. But the library is not maintained anymore, and it didn't fully answer what we needed to achieve. So we went with one implementation of the library to get to what we wanted to achieve. So now that we have a potential way of assessing a solution, we need to first define objectives with the solution. So the first objective is to have faster feedback loop for developers. And second one is to have a green CI test whenever there's a first push from a developer, because it's painful for developers to push code without knowing if the test will be green or not in the CI. So what we've implemented is a workflow that fits what we do at BackMarket. It may not apply to every code base, but it really is perfect for the code base that we have and the workflows that we have for the release. So the first thing that we implemented is on the main branch that is built on the CI, we run the test for coverage with the dynamic context enabled, as shown earlier. And we upload the coverage report to an external remote server. We use AWS S3, but you can use whatever you want. And we upload a file based on the commit SHA-1 of the head branch, at which branch we are generating the coverage report. This is important because for the solution to work, we need to have a report that is similar to the base branch of what developers will have when trying to get the information of what tests are impacted by code modification. Otherwise, you may have code that is outdated. You may have tests that are not included anymore in the report, so you may not have stable reports. So we have to find a way to have the correct commit SHA-1 based on the base SHA-1 of the developer branch. And then on pull requests that are built on the CI, we basically retrieve the correct coverage report based on the SHA-1, and we end up retrieving the coverage report SQLite database. And with that, we also apply the git diff on the pull request to get the list of modified files, modified test, added test, deleted test, everything. And with a script that basically runs the SQL query that we've shown earlier, and also run all the new tests and modified tests, because for new tests, it's normal to always run them. We then merge that to the list of tests that we need to run. And to assess this solution, we also sent a stack notification to get an idea of how many tests we would run by using this solution compared to the total number of tests that we have in our code base. And we also calculated the duration that it will take to run only the partial test on the CI versus the total number of tests that were taken by the full test run on the CI. So assessing the solution even further, we went to actually use partial testing for real on the CI. So not only trying to get the list of tests run, but actually run only the tests that we need to run based on prior modification. We still kept the full test job alongside it because we were still not sure that the solution will catch everything that we needed to catch, because there may be some edge cases that we didn't handle at the time. So we needed to be sure that we would not let test failure pass to the main branch. So by doing that, this gave us a real feel of the duration improvement and stability of the solution. So you can see in the graph, for instance, that most of the time we gained a lot of time compared to the total number of tests that we would run on the CI. So this was quite promising. But now we needed to test the stability of the solution, of course. So looking back at two objectives that we defined at first, does the solution meet our expectations? So the first point was faster feedback loop for developers. This one, I'd say it's partly resolved because, well, developers have faster feedback because the CI takes less time to run, but they still need to push to the CI and wait for it to run, which can still take a bit of time. So this is a bit resolved, but not entirely. And the second point was to have green CI for test when the developer would first push his code. So this point is not resolved because even if the CI is faster, the developer will still have no way of knowing which test it would need to run before pushing to the CI. So we didn't resolve this one yet. So how to correctly answer the two objectives? Well, Hunter's partial testing, but this time locally. So we asked ourselves, instead of running partial testing on the CI, why not running it on the developer machines? Basically, this is exactly the workflow that we already have on the CI. So we kind of already assessed that it would work. But this time, instead of having it on the CI on pull request, we would just run the workflow on local environment for developers. So we will just need to adapt a bit to workflow to assess for local usage, but the workflow will basically be the same as one we have on the CI. So the developer workflow would basically go from what we have on the top to what we have below. So before partial testing, as said in the beginning of the slides, whenever a code is updated and the developer doesn't know the impacted test based on the code modification, he will just push the code to Git. Then the developer will be waiting for the CI to either pass or fail. Sometimes it fails, it happens. And then the developer will update failing test if the CI is failing, and he will push to Git again, and then the CI will hopefully pass, but it's still a bit of time that is lost waiting indefinitely for the CI to run. With partial testing on local environment, we have a different workflow where basically the developer will update the code, and after that, the developer will retrieve the coverage report from AWS S3 or whatever remote server we are using. And if it's already in the local environment of the developer, we won't get it from the remote because we already have the coverage report on local environment. And then we will only run the impacted test based on the files that are modified. So in the Git diff, the same result as we will have on the CI. And then the developer will push to Git, and this time, hopefully, the CI should pass. So basically, by doing this, we are removing the step where the dev are updating the code and pushing without knowing beforehand if all the tests that are impacted by commodification are actually handled. So let's do a quick demo of the workflow to give you a better idea of what we've implemented for developers. So basically, let's say I'm a developer, I'm working on a branch, and I updated a file that seems to be a core file, but I don't know at which part of the test are impacted by the code modification. So I want a simple command that will download the coverage report from S3 with the correct SHA-1 based on the commit head of the base branch. Then it will generate the list of tests that exist in the code base. And after that, it will generate the list of tests based on the Git modification. And we can see that we have at least almost 100 tests that need to be run based on 18,000. And then the developer can see actually the tests that would need to be run based on the prior modification. And there's a second command that will just run the test, the partial test, to only run the test impacted by the code modification. So it's running. And voila, it took 11 seconds to run only the test impacted by the code modification instead of having to wait either on the CI 10 minutes or having to run the full test suite, which again can take 45 minutes. So this is clearly not bearable for developers. So with this solution, we have technically three possible scenarios. The first one is the one I showed. You basically run the first command that will list the tests that need to be run based on code modification. It will give you the output of how many tests will need to be run. And the second command would be to actually run the test. So it will basically pipe the file where we store the test into the test command to run the test that we need to run based on test functions. And it will basically run the test. The second workflow is a case where we don't have test to run because, for instance, you're updating a documentation file or you are updating a file that is not tested yet. So if you came across this situation, please add a test. Then the third workflow is whenever a full run is required. So a full run is required if, for instance, you are modifying dependencies because it's hard to assess the impact of updating the dependencies in Python. So in that case, it's better to just run the full test because we don't know if by running partial tests on this, we will be able to get any breaking change in a module. So it's better to just give, we don't know about if we need a full tester or not. So let's just run the full test. Okay. So looking back at our objectives again, does this new solution meet your expectation now? So the first one was about having a faster feedback loop for developers. So I think that yes, developers now have feedbacks before pushing to the CI. So this is way better than waiting maybe 10 minutes or a bit less on the CI. And the second point was about having green CI before running, before pushing the code to Git and waiting for the CI to run. So mostly yes, because now developers know beforehand, before pushing to the CI, all the impacted tests that would have been validated before pushing it. So there still are some cases where it's hard to get this right because if you are updating a core part of the code base that is really used a lot in the code base, you can still end up with a lot of files to run. So for instance, half hour of test, which could take up to 20 minutes. So there are some cases where it's still not helpful, but most of the time with the feedback we got from developers, it was helpful in a lot of situations. So speaking about feedbacks about developers, so in order to assess not only with KPIs and metrics the usefulness of the tool, we also wanted to assess, to receive feedbacks from the developer actually using the tool. And what we wanted to have is, we wanted to know if the tool did improve the feedback loop for developers and if the tool was easy to use. And it will ensure that the solution works not just by numbers, but also by having human feedback and tackling every developer use case, which could all have different needs. And the response we got so far are pretty positive. So people are mostly happy with the tool, and they will even recommend it to other developers in the team. So that means that there's an utility of having this tool implemented, which is nice. So there still are some challenges and limitations with the solution. So the first thing is that you need to be careful about file updates that require a full list of tests, because as we said earlier, if you update requirements, it's hard to assess if there's an impact on the full test suite or not. You also need to be careful about file renaming, because we were able to handle most cases with that, but we didn't get it right at first time. But on renaming files before querying the coverage database, you first need to use the whole path of the file in the SQL query, because coverage doesn't know yet about the file rename. So if you use a new file name for querying the database, you will then get an empty result because the file doesn't exist yet on the previous commit. Running tests through coverage had a big overhead. So when we measured how much overhead it would have, it was about a factor of 2 for our cases. But this is not that much impactful, because in the end, we still are only running this specific workflow in the main branch. So pull request would still run only the test without coverage. So this is a trade-off that is okay for us. And coverage report is sometimes only generated after dev started rebasing his branch from the latest commit. So in that case, it's also a trade-off we could do. Maybe we can just still use the latest coverage report that is available, with the risk of having some data that is inconsistent. Otherwise, there's no real solution for this, and we didn't really find it right now. And partial testing is not always useful when some central piece of the code is modified. If you have a lot of tests to run because the file is heavily used, then it kind of defeats the purpose of using partial testing in the first hand. So we have some ideas about further possible improvements with the solution, because right now developers have to download the coverage report from S3, which can take up for quite some time. It's 200 megabytes to download the report, so it's quite heavy, especially on developers that have slow connections. So an idea could be to have a web service that could list the tests to run based on base branch SHA-1 and a git diff that the developer would have locally. So we basically would call an endpoint and send the list of git diff and the SHA-1 that was used at the time. It will basically offload the work to a server rather than the developer's laptop. And we will not need to download the coverage report from the remote server locally. And so the faster feedback loop will be even faster, because we will not need to wait for the download to occur. And the second thing that we want to achieve also is to running only partial testing on the CI for real without the full test job. So for now, we're still not able to do so, because one thing that we noticed is that by only running some tests and not the full test suite on the CI, we will end up with some tests that we're failing because of some hacks on the code base, the test suite. And we would end up with tests that were not failing on the full test run, but were failing on whenever running only part of the test. So we're still not confident yet to do this solution. But even if there's some edge cases with that, it's still okay, because on the main branch we will still run the full test suite. So we will still have a backup, and once a code is ending up in the main branch, we still have a way to know if a recent merge would have broken some tests. So that's the trade-off that we could accept if it's not happening a lot. So key takeaways from this presentation. So partial testing is mostly useful on big code base. So if you have a code base that is small because you don't have a lot of people working on it, it's quite recent and maybe correctly structured, you may not need to have this solution, because it will be fast to run the test suite, or you precisely know each time which test you need to run. The implementation may perfectly fit all workflow at BackMarket, but maybe it's not the case for other companies. So you have to be careful about your expectation, and you have to assess if the solution and this specific workflow could be useful or not. An important thing also that we did is that the same, similarly to asking for feedback when developing features, it's good to have feedback from developer when developing feature for developers, because they all have different needs and expectations, and it's fine to have metrics and assessment of solutions like we did on the CI, for instance, but it's always valuable to have human feedback, because in the end they will be the ones that use the tool. So if you don't take feedback from developers, you will not know if people are happy with the tool, and you may end up with people just not using the tool because in the end they find it not easy to use, which should be a bad thing. And also MVPs are nice even for developers tool. We could have ended up with a solution that the solution with a web service and everything on local on a remote server environment. But if we didn't validate first that the solution was valid for both developers and was stable on the CI, we may have ended up with a tool that nobody will use, because they will maybe not understand what it is about, and maybe in the end we would not have a tool that is actually useful. So it's important to go step by step, implement things on the go, and you validate at each step that the tool is useful. And that's it. Thanks for listening. And if you have questions, I'll be happy to answer them.
do you update the coverage database? Do you still like database?
Oh yeah, it's a good question. So our new workflow, it's updated on the main branch. So basically, we have the main branch that builds a new coverage report every time a code ends up in the new main branch. And then pull request will use this coverage report to get the most relevant data based on the SHA-1 commit on the base branch of the pull request. But we didn't find a way to reconstruct the database from time to time because with the code changes, it's hard to generate a report based on an existing report. So this is a workflow that fits for us, but maybe if you have a lot of pull request merge from time to time, it may be hard to get it right because it may not fit your workflow. So yeah, but on new workflow, it's built on the main branch. Yeah. Yeah.
Similar question. I thought when you create a pull request, you still use the coverage from the main branch, not the one for the call that you just called now.
Sorry, I didn't.
And when you create a pull request, you have new code in there.
Yeah.
You are still using the coverage for the main branch,
Yeah.
not for the new one.
Yeah, so basically, when you have a pull request, we do a match base of the branch that the developer has created and the base branch it's based in. So we get the exact SHA-1 that we need to use. So we end up checking in the remote server if we do have generated a report for this commit. And if we don't, we just don't read don't execute the partial test assessment in the CI. But as said earlier, maybe we could do a trade-off and still run the partial test solution, even if the solution is a bit inconsistent, because you may end up with a coverage report data that is a bit outdated or too recent. So it's a trade-off to do, I guess. Other questions?